these past few weeks, Ronald, Christopher, and I were assigned to estimate population parameters for about 10 different topics from our school. Some of these topics included whether you supported the wall or not, whether you would like to go to a state university, whether you could identify a tarpon from its picture. So to do this, we had to go survey multiple classes in order to calculate the confidence intervals on some of these topics. So in order to do this, we had to use a random number generator to give us one number of four different departments in the school. So we used the math department, social studies department, science department, and English department. So after using a random number generator, we ended up with Mr. Estrada's class, Mrs. Berner's class, Mr. Grant's class, and Mr. Tenelsto's class. So we went to those classes, asked them these questions, got our data, and started our calculations. So a confidence interval is used to estimate population parameters for a certain data. So after we got our data, we use the calculation, the formula for confidence intervals, which is the mean plus or minus the critical value plus standard error. In this case, standard error was PQ over N. So we solved all that. We used the 90%, 95%, and 99% confidence levels in order to estimate a proportion, whether it be from 0.5 to 2.5, 8.5 to 9.5. We use that to estimate the overall view of our school. So some of these data you might be surprised to see. Also, there might be some bias in them because some kids want to act cool or like not be embarrassed of themselves. So Ronald and Christopher are here to talk about two topics in particular: the kids who dye their hair and kids who can identify a tarpon through its pictures. This was a very tedious and long process, and we hope you like our findings.
Hello, my name is Ronald Merga, and I'm going to be talking about the first question in our series of questions as to the proportion of students who wear their natural hair color. My initial thoughts when asking this question is that once we had already chosen one classroom per each department of the school randomly to enter the classroom and get a visual approximation of where our proportions may land. We looked out for any particular hair color that may spot out that it is dyed. We then actually asked the class who wears their natural hair color. To no surprise, by a show of hands, the majority of the students in each class raised their hand. We then asked instead the counter question as to who does not wear their natural hair color, and we got a smaller set of people who raised their hand, and we simply subtracted them from the entirety of the class to get a proportion of students who wear their natural hair color. We then proceeded to actually do our confidence interval test. We got our z-scores that corresponded to each test and proceeded to make a 90, 95, and 99% confidence interval. With our 90% confidence interval, we determined that the interval of the students that wear the natural hair color is between 0.812 and 0.912. With 95% confidence, the interval is between 0.805 and 0.919, and with 99% confidence, it's between 0.787 and 0.937. One source of bias, that may have altered our confidence interval is the bias of social desirability. This is where, in this case, students may change their answers in order to fit in with other students. Seeing that those who may dye their hair are a minority in comparison to those who maintain their natural hair, may actually change their answers in order to fit in. While we can only ask to get statistical and reliable data, we cannot actually make sure that each person tells 100% the truth per each question. It is up to those being sampled to actually allow and give conscious and truthful answers.
When collecting data about the proportion of students who can identify a tarpon from its picture, I predicted that no more than a third of the people in class would actually know what it is. It turned out that I was right. Although Miss Berner's class has the highest proportion, it still wasn't statistically significant enough to make the data not be representative. In Mr. Tanasio's class, the proportion of the students that can identify tarpon from his picture was 1 out of 35. In Mr. Grant's class, it was 4 out of 24. In Miss Berner's class, it was 8 out of 30. And in Mr. Estrada's class, it was 6 out of 42. The mean proportion was 0.157 and the standard error was 0.03. We then proceeded to find the confidence intervals for 90%, 95%, and 99%. That being said, with 90% confidence, we can say that the proportion of students who can identify a tarpon from his picture is between 0.108 and 0.208. With 95% confidence, we can say that the proportion of students who can identify a tarpon from his picture is between 0.98 and 0.216. And finally, with 99% confidence, it is between 0.08 and 0.234. After asking each classroom if they were able to identify a tarpon from its picture, a simple bias would have been that after students who actually know the answer raise their hand, they might have secretly proceeded to tell others what a tarpon is. This could have caused the proportion to increase. However, in the end, the proportion still remained very small and representative enough.